webinaire. Bienvenue à tous les participants. Merci de suivre ce nouveau webinaire Visit qui aujourd'hui va traiter de la gestion des données, notamment au niveau des solutions des voitures connectées et de l'automobile, et comment appréhender ce management des données dans ce nouveau monde des voitures connectées. Avant de commencer, je souhaiterais vous donner quelques informations générales sur le déroulé de ce webinaire. Donc, la session sera entièrement enregistrée et sera disponible et mise à disposition suite à ce webinaire. Nous vous ferons passer le lien par email. Durant toute la session et la durée du webinaire, tous les participants seront en mode muet. Néanmoins, vous pourrez intervenir avec nous à travers le canal questions que vous avez à disposition sur le panneau de contrôle de la session GoToWebinar. Donc, n'hésitez pas à poser vos questions tout au long de la présentation. Vous verrez à travers l'agenda qu'à la fin de la présentation, il y aura une petite séance de Q&A. Je me présente, donc moi je suis Frédéric Maraval, je suis responsable produit au sein de la société Easy et aujourd'hui je suis accompagné par Sassan Montasseri qui est le président d'ITIA et qui fera la présentation des slides concernant toutes les solutions de gestion de données. Donc, thank you Sassan for assisting me during this webinar. Cette présentation se fera en anglais pour la partie slide, mais vous pouvez intervenir à travers le canal questions en français, il n'y a pas de souci, je ferai la traduction pour Sassan. Avant de lui laisser la main, voici l'agenda de ce webinaire. Donc, on commencera par avoir une overview un petit peu du marché automobile et de l'industrie automobile de nos jours et l'évolution qu'il y a eu notamment avec les voitures et les systèmes connectés. Ensuite, il y aura une vue sur comment la gestion des données s'est passée au sein des véhicules modernes et leur architecture. Et pour fédérer un petit peu toutes ces notions, Sassan montrera comment on peut traiter cette partie-là à travers les solutions de gestion de données d'ITIA. So Sassan, I will give you the control for starting your presentation. Give me just 1 second.
Please do.
So you have the control. You can start your presentation.
Okay, that's great. So I assume you guys are able to see my screen.
Yes, it is perfect. You can go.
Okay. Good afternoon, everybody, and thank you for joining us for this session. Today, we want to talk about data and data management in the automotive industry. And I would like to share with you, from my perspective, what we see from the evolution of this market and the relation that it has with the data, how the market evolves, and how we are going to go toward the software-defined environment for the connected vehicle that they are going to become smart. You know, we are familiar with the terminology of smartphones, but now we are getting ready familiar for the terminology of a smart automobile and smart transportation. So there's large amount of data generated in vehicles, and that comes from the vehicle itself, comes from the drivers, comes from the passengers in various forms. And interestingly, you know, if you look at the vehicle, it's built from microprocessors and microcontrollers that they are all deployed inside the vehicle. And these are the parts that become smart for us. And these are the parts that are going to you know, allow the manufacturer to bring more innovation and understand the surrounding inside the vehicle with the passengers, with the driver, and help us to understand what's going on. So today, we are going to expand on the smart vehicle data management challenges and introduce you to a cutting-edge data management for analytic and the processing of data right on the edge. When I say edge, I'm referring to the vehicle here, because we are assuming everything happens independent to any connectivity with the architecture that we are supporting for emphasizing on expanding and making the in-vehicle experience more powerful. And in my opinion, whether you're building passenger vehicles, whether you're building taxis or delivery trucks, or even these mobile shops that they come to people's house, take care of their dogs or take care of their haircuts or whatever, these are all part of the same tool chain of the automotive and transportation. And the combined multiple mode of transportation even can go to scooters, buses, train, and metro. So it's a pretty interesting, arena that we are arriving in the form of what we call automotive and transportation. So the industry, it's going through significant evolution right now, and vehicles are becoming more and more intelligent, and particularly by the software that is getting more powerful. Look at Tesla. So, or other, vehicles that they are coming to our lives. So there are technologies that are being adopted inside these vehicles. Can be LiDAR, can be vision processing, path planning, the Ethernet inside the vehicle. So in addition to all those things, one thing that I want to, take your attention to is the time series data stream analytics and real-time data management that plays an important role for any components that you're building for these vehicles. The historical method of data management no longer is going to be applicable with this evolution of smart vehicles that we are facing. These vehicles are going to be autonomous. They are going to be drive on their own. They're going to fix themselves, self-fixing vehicles. We expect them to do effective battery management. We want the insurance company to tailor the application that they are building for the vehicle. So, you and I pay less because we are good drivers. So the preventive maintenance to maximize the driving time on the road, the in-vehicle experience, they're all causing upheavals in the automotive market. So whether it's for automakers, whether it's for the maintenance centers, whether it's for the driver insurance company, everybody is involved. And in my opinion, there are three important things here that we should pay attention. The first one, it's data. Second one is artificial intelligence. And the third one is machine learning. So let's look at the data first in the modern vehicle. And in the modern vehicle right now, I don't know if you guys heard about this or not, but that's pretty interesting. They have about they are saying that the smart vehicle or the modern vehicle, they're not even, the smart vehicle, they're in the modern vehicle, they're generating over 25 gigabytes of data per hour, up to 4,000 of gigabyte in a typical day, 4,000 gigabyte in a typical day. So this is a massive amount of data that's coming in, and it's coming from all the microprocessors and microcontrollers that I shared with you, that they are inside the vehicle, and they are going to get all this raw data, whether it's coming from telematics, whether it's coming from infotainment, and whether it's coming from the mechanical systems. We need to understand, we need to have them to talk to us, tell us what's going on, and we need to make sense of the pattern of information. So we're going to get lots of raw data, and we're going to convert them into meaningful information. So when we are working in this scenario, we see that these engines, how they performs, we see how the brake performs, and we are generating all sorts of data that's coming our way. There's a company in US called McKinsey and Company. I don't know if you heard about them or not. They are estimating that the amount of data is being generated by vehicles is going to be worth over 750 billion by 2030. So auto market players, they can capture tremendous amount of opportunity by innovating and building, by paying attention to data. And this is what we are going to explore today, and we are going to see this vehicle that they are actually turning into a mobile data center, in my opinion. They can talk to satellite, they can talk to traffic lights, they can talk to the tool boats, and it's just phenomenal how all these things are coming together and how the diverse data can help us to allow the vehicle to inform us about the vehicle health, about the position, about the traffic condition. And in order to provide all this predictive maintenance, we need to go through this massive amount of data, process it on the edge, and we need to be able to convert that to meaningful information so we can make sense out of it. Basically, there is something that's, I don't know if you heard about that or not, it's called CASE. So what is CASE standing for? It's this evolution, it's based on CASE. And I will explain to you what I learned about that. And driving all these changes in the automotive market really relies on these four important things. The first one is vehicles are becoming more connected. Like you and I, we are talking, we are exchanging information, are like human beings. So they are connecting to everything. They are connecting to other vehicles. They are connecting in a way that they can be informed about the late depart. They can basically talk about anything that's going on in surrounding that. It's important. The second thing is about autonomous. We hear about these things, autonomous vehicles, and autonomous. It's a very, very complex concept, and that's why I brought you data, artificial intelligence, and machine learning. That plays an important role here. So autonomous, from the initial driving to the late departure to the driver sensitivity for the blind spot, and full autonomy is going to get applied to the vehicles. And the third thing we are going to see is going to be about shared vehicles. People no longer want to have the cost or have the responsibility for the entire car. They rely on sharing what we have in the US we call zip cars or Lyft and Ubers, and they're using these cars and they just use it for going from point A to point B and they get done with it. And the fourth thing is electrification. Every manufacturer that we are dealing with, they are talking about a milestone that they are going to introduce the electric car if they haven't, and many of them already have. So let's look at each one of these more carefully and see what we can get from them before we can go through the data management part of it. The ability to function securely and safety. When we talk about this connected vehicle, the security and safety is very important. And I want to bring that to your attention because data safety and security is so the ability to function securely at the highest speed, it's necessary. And the edge computing paradigms give this vehicle increased intelligence for data processing power, interoperability power to do their job. And now you have multiple communication channels that are all connected to the vehicle, and the vehicles are going to talk to each other. Vehicles are going to be aware of each other infrastructure, or basically in a way that when they see a sign that it's going to provide them with some information, and they provide some information to the signs, or they can be the tool boats that they provide the information. When they say, call that V2V is V to vehicle to vehicle, or VX means that vehicle to everything. So the communication needs to be happening, and the communication of the data needs to be secure. So that's an important part, because you're also going to have cellular connection these days. We're talking about this mobile vehicle are going to be able to have all this, luxury of, communicating with the outside world, and communication plays an important role. Another thing is in an autonomous scenario, from the early driver assistance, the blind spot warning, to full hands-free autonomous driving, there's a complex algorithm in place. No one expects this initial vehicle that they come out be perfectly correct and have all the algorithm on the autonomous vehicle 100% working. And quite frankly, I don't know when we get to that 100%, because we already have seen these issues, with Tesla, that the autopilot problem that they have, and the algorithm, it's just settling itself down and it's growing. So these algorithms, in my opinion, are going to evolve for many, many years, and probably evolve forever. And at some point then we need, we get to the point that the evolution is part of the algorithm itself. But most auto manufacturing are using data, artificial intelligence, and machine learning to help them to get ready for dealing with such an algorithm that deals with the real-time time series data, because the data is being generated, it's massive, huge amount of data is involved with this algorithm. And at some point, this algorithm, needs to be taken care of. The next thing that I shared with you, it's a share, it's a share services, and they're going really fast. And things like in US, as I said, we have Zipcars and Lyft and Ubers that they are heavily, relying on getting some intelligence on their own, so they can deal with each individual passenger in a way that the person can feel like they're driving their own cars. And what we see more and more is the electrification of the vehicles. This is one thing that's going to be probably one of the major driver to deal with the real data refining and managing, because the observation sensation for electrical performance, it's going to the critical factor right now. And being able to manage the power that a vehicle is using, how much power it's getting used, because they try to emphasize quite a bit on the power management, efficiency of charges. It's going to be really critical, and the battery efficiency, so they can see miles per gallon for electric vehicle MPGE, and the range of vehicles are looking to be optimized for that area. And that's going to be a big hang up right now. How often do I have to charge the car? People do not like to stop and charge the car. They want to keep it on the road as much as possible. And again, that comes to the fact that the data needs to be managed very efficiently, and the artificial intelligence and ML are going to also play an important role. So the idea of vehicle architecture evolution, this is something that it's from NXP actually, and they are data generation, and there are lots of architecture that we are seeing, but there are three main one. The first one that you see on the left, it's the one that we have right now, and the one that's in the middle, that's refined as a domain, and the third one is the future, and we see a little bit of that is a zone based. And basically, when you look at these things, there are different components. For example, when you look at this thing in here, right now, all the components that you see here, like infotainments or the telematic systems or the driver assistance systems or the dashboard, they all are separated, and they are deployed they are deployed in the various part of the vehicle. And when you think about this, it's an individual subsystems, and the whole manufacturing process since the Henry Ford, in US, we have gotten to the fact that bunch of subsystems are going to integrate together, and they go through the canvas that we don't want to go to the detail of that. But what we try to bring to attention here is that this is evolving. So from this here, we go to the domain base, and each one is going to have its own domain control, domain for connectivity, domain for various parts, and they are going to all communicate to the central gateway that will be inside the vehicle. And then the last one is the it's a zone based. That's the part that you will see lots of software in there. Software defined architecture is going to be dominating the zone based, because the domain, it's going to work on virtualization, enabling high flexibility, and enabling and disabling updates. So security also becomes important, because you don't want people to come here and take advantage of the car. So basically, the domain-based that I shared with you, it's going to be the architecture that provide the perfect structure for FN data management. Database can be attached to each domain here that we are talking, and database is going to be attached to the central gateway. So there needs to be orchestration between all this domain data management and the central gateway that we are going to face. And then for the zone-based architecture also, as we said, physically it's not no longer important how you deploy your card, because each zone has its own characteristics and they can be attached to the zonal gateway. But again, the data management for each platform is going to play a role in here, and the data management is going to work with this central computing, and the database can be attached to each central compute platform to manage optimize. And then again, remember that whether we talk about this domain-based architecture or zone-based architecture, in my opinion, they're all built with all the systems are built with microcontrollers and microprocessors. So all these microprocessors and microcontrollers are going to evolve in the way that we are going to deal with a massive amount of data. So the question here is that there are 7 questions. If you answer yes to any of these things, we should definitely be talking. And we can definitely assist, because our word, it's a word of data management, data processing, and I will explain to you what we have done and what we have brought to the table with the train of thought that I told you that, okay, if you notice, data is important, artificial intelligence is important, machine learning is important. So we've been focused in the past several years, has serious research and development to ask ourselves, okay, how should we prepare ourselves to talk about smart vehicles? And so if you say answer to any of these questions, are your devices now generating significant amount of data? Do you have a good way to structure and put a framework around the data? Do you have a way to analyze that data in a way that you can make a decision in improving the performance of the vehicle? Do you know how to manage historical data and help your customers? Are you using artificial intelligence or machine learning with device data? Is the data going into those machines structure in a way that makes them efficient? Are you looking at how to make your product smarter, how you make your vehicle smarter? If you answer yes to any of this, we definitely love to talk with you, because that is how we can help. That's how we can add value to what you are doing. So as I explained to you, we recognize that we need to separate our focus in 2 different areas. We need to have a data management platform for processing, streaming live data for microcontrollers and for microprocessors. So we went ahead and we built an application. We built a data management platform for microcontrollers, and this is a very, very a smart system for working in the tiny environment that they are doing. They have really conservative with the footprint, but still they want to be able to have a real-time time series data processing. And then we also went ahead and we built ETIDB SQL for micro processors. These are multi-core systems, really, really heavy-duty platform like S32G or R-car stuff that, they want to be able to do any processing, anything that needs inside the vehicle. So we divided our attention to 2 different parts for microprocessors and microcontrollers, and we are comfortably, able to offer our solution for any processors or any chipset or any real-time operating system. But there are 4 fundamentals in here. First of all, you have to pay close attention to safety. Safety plays an important role in here. As you're building systems for future, you need to make sure that, the system, you put passengers in there, you put, drivers in there. So safety is number 1. The second thing is security. And the third one is reliability. These are the first 3 fundamentals that is really, really important. And the fourth thing is certifiability, because you want to certify your product. You want to make sure that, it's reliable, it's safe, and it's secure. And now, you can come and say, okay, I'm going to get the certification of various forms that we are aware of that exist for the auto industry. And as I shared with you earlier, one of the challenges that Tesla has with this autopilot is because they have no certification that they're going through, and that's causing issue at some point. And the legislation and the legislative are going to catch up with this, and they're going to create some challenges. So this is very important to pay attention. These are the four fundamentals that we pay attention, and we try to build our system around that. So give you an example, um, when we talk about automotive transformation, we talk about automotive parts being able to do self-healing. We don't want them to wait until they break and we go to the mechanic and say fix it. So how does this work with the software-defined architecture that we talked about? How does that work with the software arena? So repairs are carried as a part of predictive maintenance, and when any of the assets in the car, it's suggesting a failure, or before the failure occurs, we want to capture that. And the significant amount of data needs to be collected and needs to be analyzed, and we need to be able to get in the mode of problem determination and using self-managing. So how does ETI helps in here? How did we go about that? So if you look at on the left side, we have the features and functionality. We build the engine that it's able to, it has two parts. It's a dual engine, offers analytical data processing. It also offers transactional processing. So all the microprocessors and microcontrollers are able to work in the both modes, and they can stream the data in, and they can also work with the historical data. So the real-time streaming and the high performance and the security, and we build the time. This is the time series foundation. It's not like other databases that they say, okay, we support timestamp, so we kind of think we are time series. No, we build the foundation and based on the time series. So these are features, and they are like, okay, so what? You do all these things, what does that mean? Okay, when you do all these things on the left, then you can talk about remote sensing. Then you can talk about preventive maintenance. You can talk about forecasting. You can talk about real-time data management, where when you set up the stream processing that I showed you on the left side, on each remote device, you can execute continuous query, and you can have a secure WebSocket that helps you to sense the action that's happening before the problem happens. You can record the device historical data inside the ETI DB, and you can integrate it with your preferred artificial intelligence package, and make sure that the breakdown model it's monitored, and you can apply the real time to the data stream. You can replicate the device setting, and anything that relates to down sampling and group cross multiple dimension, it will help you forecasting. So these are the things that they come together, and we want to make sure that you see the value from what it's going to help us. So let's look at this scenario. Let's look at this as a component that we have inside the vehicle that we are monitoring, and it's connected to 5 different sensors. One sensor talks about the pressure, one sensor talks about the temperature, series of sensors, velocity, and density and optical. You look at the pressure in here, you can see that everything is making the same behavior. So there's nothing to be worried about. Whereas when you look at the temperature, oh my God, this is something going on in here. We are going to, see something happening. You look at the velocity, nothing is happening in the velocity sector, whereas density and optical are also tell you that something is wrong. So before things happen, we are able to look at the data, we are able to capture that, we are looking at the pattern, and we are able to help the system to make a decision. And all these things that are coming together are going to play an important role in the future of where we are heading with the preventive maintenance and the self-healing of the vehicle that I used as an example. Security plays an important role. I explained that to you, that security protocols are important. We pay attention to that. We provide encrypted storage, authentication, and we build our security agent that is smartly and intelligently sits inside the database and understand the behavior that you already train it. So if anything happens that is unwanted, it can help you to understand it. In addition to that, we are conformant to the principle of IEC ISO 62443 and ETIA STL secure development lifecycle. It's a practice that is heavily applied to meet our customer security concerns. And the conformancy is each cycle begins with security planning and training. A threat model identifies and prioritizes product security risks, and then security consideration are built in the design, and secure coding that leverages the static analysis, coding standards, vulnerability and penetration testing leads to incident response and communication. So it's very important to pay attention to security, and we make sure that this is taken care of with ETIA DB. And when you look at the smart vehicle, remember I told you that we are getting to the area that the software-defined architecture comes to the place for the vehicles. And basically, the data collection is going to be really, really important. There's tremendous amount of data that's coming in, and the vehicle must be able to understand and be able to capture that data, and need to be able to filter and aggregate and make sense of what is coming in, whether it's for V2V, whether for V2X, or whatever. The data collection and data processing import a very important role. You want to aggregate the time series data, and you want to be able to build application services that it's helping you to completely manage the data without any independency. You want to be able to monitor the cost of the power that's in there. You want to be able to do disaster recovery, engine data management. All these things really surrounds data and data management and data processing, and that is what we paid attention to make sure that when the sensor data comes in, whether it's from the camera, whether it's from other components, you can manage it in your smart vehicle. Also, if you remember earlier, I talked about sharing. That I told you that manufacturers are understanding that data, the vehicles are going to be deployed in the field, and it's going to be utilized by number of people in the form of data sharing. Data that's generated by sensors for vehicles, controls warning systems, the scenario that we have in here, it has its own important role, because you want to make sure that the information that comes in for passengers, it's safe, it's secure. So if you're building any application, it's not getting available to others. So the harassment, the assault, the robbery of passengers, because it's not a private car anymore, it's like a public transportation, but it's in the form of share. So you want to have a full oversight of the driver, of the vehicles, of the trips that you're making, and you want to make sure that if you're building application for niche for niche vehicles, this is something that the data management is also able to support the flexibility that you require for your own system. So we pay attention for making sure that when a large volume of data it comes into the system, we can capture the valuable information, we can make it security available, and we can help you to filter and aggregate. Yeah, the next thing that we pay attention is for smart vehicles. As I told you that we are getting ready for the arena that we are going to have smart cars, and the database and machine learning and artificial intelligence play a very, very important role. The foundation of the data management must be such that it can support the machine learning, it can support the artificial intelligence, and they definitely have different algorithms, they have different foundation, and this is what we are paying attention to. So when the stream of data arrives, we can train the vehicle to act, we can have them to do the preventive maintenance. So what we did, we pay close attention to the compatibility that needs to be here. I also talked to you about the different domains. So ETIDB and the domain zone-based architecture, it's something that, it's really, really important. No longer the CAN bus, it's going to be the main dominant. The scalability becomes important, and the central gateway and the domain architecture are going to be important. So what we did with ETIDB, we make sure that it's easy to embed, whether you have microcontrollers, whether you have microprocessor that relates to various domains, whether that's for infotainment, whether that is for, EV and the powertrain, whether it's for body comfort, whether you want to use any desired operating system, any desired hardware architecture, we make sure that that's something that we can support with the scalability, that you don't have to be worried about putting too many wires in the car, because as I told you, wires and components are going away and software and virtualization are going to take over. And we want to make sure that the distributed stream processing, distributed query processing, and support for the central gateway. There will be a central gateway here that is going to be communicating with all this data management that are in various domains. And on infotainment data, body comfort, they all come to be. And on top of that, you got to make sure the data management platform that you have in this market is going to be cost effective. So that has been our focus. And what we are believing that manufacturers are going to build the new systems. They want to be able to generate more revenue. It's all about monetizing, So when you build the operation for various, metrics that you put in your vehicle, you want to be able to understand the data, you want to be able to analyze the data, and you want to be able to, generate more revenue, sell more cars. And as you have the more understanding about the data that's coming from the environment, that's coming from the vehicle itself, that comes from the different applications, you can make the vehicle more intelligent. You can make sure that understand the route and navigation, and it can help you to build stronger vehicles. And then on top of that, another important thing is that you want to make sure that when the systems are deployed, when the vehicles are deployed, they have a way to communicate with the cloud. It's not like it's going to be 100% just on the edge. No. It's going to perform completely on its own, as you can see on its here. But at some point, it will arrive to the dealer. It will arrive to the maintenance center, which they have their own enterprise databases. So they need to be able to dump their data, and even they may want to be able to communicate to the manufacturer at some point with their behavior, with their health, with what is going on, whether it's a Peugeot, whether it's Audi. They want to be able to have direct connection to the car, and these are the things that fundamentally are important, and that's what we pay attention in building our system. So there is increased amount of data coming in. There is a connectivity that's important. There is a machine learning that's important. There is, the auto processing data that is going to be very, very important. And all these things happening by interaction that we will have with the companies that we work with. And if you want to work with ETIA and ISIT, what we will do, we will definitely get together with you. We will definitely brainstorm with you. We will share you what we have, and we will make sure that we establish sort of a partnership that you can benefit from our data processing and data management, and we can work together. So this is a summary of what we have prepared for you, and I want to thank you in advance for attending our webinar. And if you have any questions, please let us know.
Thank you, Sasan, very much for this very interesting and impressive presentation. I will just take back the control now. So we will start the Q&A session. We have already some questions, but be free to ask your question again. Et je vais passer en français pour continuer donc la session de Q&A. Et je vais traduire pour Sasan vos questions. Donc, comme je le disais, il y en a déjà quelques-unes qui sont arrivées, mais n'hésitez pas en poser d'autres. Si nous n'avons pas le temps de répondre à toutes vos questions, nous reviendrons de toute façon vers vous directement par email pour développer ces réponses-là ou donner réponse à vos attentes. So the first question, Sasan, just the time for me to translate it in English. So first question, what do you consider the main data management challenges for building application for the automotive market?
Basically, what we are encountering is many of the partners and many of the customers in this sector, they see tremendous amount of data coming in, and they definitely are, you know, the ingestion of the data and being able to store that because many of the data, it's unwanted. They don't need all of it. They just need some portion of it that we refer to it as an information. So from my perspective, I think the first challenge is there's lots of data here. There's so many information. I want the data management to be able to digest this information and be able to process that for me. The stream of data that are coming in, I need to be able to make sense out of it. So I would say this is the most important part. And the second part, you know, it can be related to security, because as you are getting ready for, you know, future, you know, it's not like, you know, if you're building autonomous systems or if the autopilot is going to take over, you don't want somebody else, you know, to take over, and rather than, you know, taking you from point A to point B, take you to point C. So security plays an important role. And the third thing, in my opinion, is the scalability, because there are various components in the vehicle that they all have been working independently. Now they need to be able to orchestrate and work together, and they need to be able to communicate with the Ethernet or whatever it's in the middle that we call it gateway. So that is how I would characterize the importance of these things.
Thank you very much. Second question. What is the difference between device time series data analytics and storage for microcontroller versus microprocessors?
Well, basically, microcontrollers are really constrained. They don't have enough memory, and you generally have about, you know, 50K, 100K for the data management that you can, you know, put your systems. Whereas for microprocessor, you don't have that problem. You have, you know, much more freedom when you build application for microprocessors. Whereas with microcontrollers, you have to, you know, be really you know, careful with, you know, with the usage of the memory and with the tools that you are using. As a result, the landscape is very different.
Thank you, Sasan. Maybe the last one, so more linked to ETIA. What is the best way to learn and train about ETIA DB?
I think the best way here is, if you're in France, you can contact ISIT and register for training. We have a training program that it's online, and we work with you and we will train you, and we will teach you how to use the technology, and we will also, you know, work with you to customize your situation and establish a dialogue between our both companies.
Yes, and I will switch in French to add an additional comment. ETIA propose des workshops auxquels vous pouvez participer et qui donnent un bon moyen de voir, je dirais, en manipulant l'implémentation de ces technologies sur des systèmes. Donc ça, c'est un autre moyen aussi d'avoir une bonne vue des solutions ETIA. So Sasan, we are just in time, so perfect for your presentation. You are respecting the timing, so thank you very much. Nous allons conclure ce webinaire. Comme je vous le disais, la session ayant été enregistrée, nous vous ferons parvenir le lien une fois que nous aurons récupéré le montage, et nous reviendrons vers vous par email. Si vous avez d'autres questions, puisqu'il y a eu quelques questions sur lesquelles nous n'avons pas le temps de répondre, nous le ferons, comme je le disais, directement. N'hésitez pas de prendre contact avec nous. Donc, soit moi au niveau des ISIT, soit directement Sasan à ETIA. L'un ou l'autre des deux canaux peut être utilisé, il n'y a pas de souci avec ça. Pour conclure, je vous remercie d'avoir participé à ce webinaire et je vous dis à bientôt pour de nouveaux webinaires Isit. Sasan, thank you very much. Have a nice day on your side and thank you again.
Thank you everybody and have a great evening. Bye bye.
Merci à tous. Au revoir.